Hello, my name is Scott Mejian, and today I'll be doing the first explainer video for week 3 for discussion section 8. This problem is about the phase space of a harmonic oscillator. Sketch the trajectory of a simple harmonic oscillator over the course of one period on the phase space plane. The y-axis is the velocity rescaled by the square root of half of the mass. The x-axis is the position rescaled by the square root of half of the spring constant. Explain the trajectory on subsequent periods. Alright, so the way I'm going to explain this is using the most basic form of simple harmonic motion, which is with a um, spring on a level surface. So when you have an object pulled some x amount, you know that it's going to just oscillate back and forth between uh, this x position and negative x. Um, and you know also that when it gets to this zero position, if you take the derivative, then you'll see that when it gets to the zero position, the velocity is at a maximum. So let's try to remember that so that at 0, that's also the Vmax. And here, V is 0. So what I'm going to do now is try to explain the problem in terms of the x-axis and then the y-axis and then try to connect them. So for the x-axis, um, we're going to have our object be here, and after half the period, it's going to end up here. And then after another half of the period, it's going to end up back where it started as one whole period. So that's kind of obvious, right? And then for the velocity for the y-axis, it's going to do a similar thing. So when it's at the maximum x, it's going to be at 0, and then it's going to go up to some maximum v, and then go back down to 0 in half of a period. And then in the other half of the period, when it's going back in the x, it's going to go down to that negative and then back up to 0 again. So if we combine these, then we'll get something like this. And I am ignoring these prefactors, by the way. Or actually, I should write v instead of y. That's more clear. So again, here we have our 0, or our maximum x, 0 velocity. Here we'll have our maximum velocity and 0x. And then we'll have our 0 velocity again and negative x. And then here we'll have our negative velocity and our 0x. If we connect all these, we'll just get a circle. And that will continue on subsequent periods. It'll just, because obviously if there's nothing keeping the simple harmonic motion from going, it'll just continue. Part B asks about what would happen if there's dampening. So dampening is this concept I've underlined where basically the amplitude decreases over time. So if the amplitude is going to decrease over time, all that means is that the maximum x and the maximum v are going to decrease over subsequent periods. So if that happens, then basically all that's going to result in the graph is that it's just going to get smaller and smaller as it goes until it just stops. It just doesn't oscillate any longer. And so from here we can see that when it crosses the vertical axis, it has a lesser Vmax than originally. And then when you cross here on the horizontal axis, it has a lesser Xmax or max amplitude, right? And obviously you can see here, it doesn't really ever overlap its previous periods, but at the end, whenever that is, at some time, it will just not move anymore. So yeah, that's kind of the way I thought about this problem. Hopefully that was a good explanation.